Hi, I'm Dr. Dave Hudson, and today I'm going to talk about how to have a successful advising appointment with your academic advisor. Generally, when I've advised over 300 students in a given year, I get 25 to 30 minutes with them tops. So when you go in and you already have all coursework and everything planned out to graduation, having looked at the course catalog and the academic catalog from the year that you came in and the materials that the university provides you, the advisor gets to have a conversation about what internships are you going to do, what other things you need to do to be successful in your career, and to take those next steps. So to start to make a 5 and 10 year plan for your career. Generally, career services departments don't do a very good job of helping academic scientists and scientists who don't want to work in academia find positions. So it's really important to talk to your advisor because they're going to have a lot of the most current information and connections to help guide you with that. So for today, we're going to go through the course materials that are provided for my undergraduate institution for the current year. And I went to the University of Rhode Island, and when you go in, you basically have a set of choices for the different types of requirements that are out there. So if you look through the course catalog, you'll see each program listed with the courses that are required. But then each program has generally broken these things out and helped you to start to think about what requirements are for a given major and then what the graduation requirements are for the university, which is a little bit broader. So when you're trying to make your plan, you need to think a little bit about your goals. And if you're a biology major, you probably have a pretty good idea you want to do biology, but you may have some question as to what exactly you'll do. I was always interested in invasive species, but wanted to work on sharks. Got more into invasive species work because I got into a lobster ecology lab in undergrad and have taken it and run with it. And I've been a long-time member of the Crustacean Society now. So that's been a really great way to work on the questions that I'm interested in and the now conservation and restoration programs that I'm involved in. But I didn't know that at the time. So what you want to do is make sure that you've got the coursework that's going to allow you to be pretty flexible moving forward with opening up opportunities. This might mean taking some harder classes than otherwise, but let's go ahead and go through pitfalls you can find on some of these. So when you look at let's go ahead and just talk about the major requirements really quickly. So essentially you have a general biological sciences requirements. So if you're in the biological sciences program, you have an introductory biology course. You need to take Intro Bio 1 and 2. You generally need to complete some sort of biochemistry, cell biology, microbiology, molecular biology. These are basics so that you'll have the base knowledge and skill to then work with these organisms as you move forward in your career. If you're for the ecology pieces, you need to take general ecology, evolutionary biology for evolution. Genetics is really key, so you can. They're saying that you could take a couple of different genetics courses. So if you're more interested in human genetics and going into research that's around humans, that would be good. I took something that was more general genetics that ended up being really focused on corn for the reason that the professor's research was on corn. You do have to take a physiology core requirement, so that can be animal phys if you're going to be animal physiologist like I am, or you could end up taking an enhanced human physiology and anatomy course if you're going to go into those routes, which are generally your pre-med route, pre-dental route. We'll take something along that line. Typically, you will have to have some writing skills, so those will have each of these courses will have a W requirement. So if you look up here, this evolutionary biology course has a W next to it. So is the general ecology, meaning that you have some major writing pieces to complete during those, which will help you to write in science. So then typically you'll have to do some 3,000 level courses, 2,000 level courses, writing in major, and this is how this is worked out. Now, when you look at marine biology, this is the marine biology worksheet, and so you do have, again, required biology courses. So these are your basic biology courses, You then have a number of these others that will kind of work into the core requirement. You still have a cell and developmental requirement, ecology and evolution, molecular biology, and that type of thing. So you're working through these, and then you generally get a chance to do a number of organismal biologies. So with all these codes, you're going to have to go back to the course catalog and look at those course descriptions and talk to some students that are upperclassmen to get a feel for what those courses are like. This is also questions you can ask the advisor. What's that course like? I'm kind of between these two. Which one's going to better prepare me for my career and for the things that I want to do? Now, we talked a little bit about the physiology requirements, which are here. Now, thinking about within marine biology, you typically will have to take electives that are related directly to marine biology, oceanography, and marine ecology concepts. So these are specific to the types of techniques that you'll use, whether it's using a respirometer to measure respiration rates in corals, or using transects to do field assessments on a shoreline. These are important pieces that will be incorporated into the courses that then prepare you for the later portions of your career. Generally, in any of these science courses, it's really important to take some sort of independent study or research. So that's important because we're kind of in the business of being independent thinkers and being able to fuse all these things together, be able to use information we've collected from a variety of different areas and synthesize something new. So the next piece is really looking at how the rest of the program is put together. So if we were to think about the different chemistry requirements and the different mathematics requirements, the rest of the requirements that you need for the program, for the basics, it's really important to look at this section. Because if you don't have the requisite chemistry requirement or the physics requirement, for an upper level course, you cannot take some of the upper level undergraduate courses in your major. So it's super important to get particularly the chemistry, the math, and the physics done within the first couple semesters so that you're not languishing and potentially lengthening your time and the amount of money you need to pay the university. So really important to make sure that you're focused on that. But there are some hang-ups and bang-ups here. So when we think about Chem 101, 102, that's really important to think about like the first few chemistry pieces, and whether you need to take intro to organic chemistry and biochem, or organic chem 1 and organic chem 2 with lab. So this is a mistake I made. I made the mistake of thinking I'm going to be interested more in biochemistry. I really want a chance to take that. It looks like a lot of graduate programs aren't requiring organic chem. I was wrong. I had to go back and take organic 1 and 2 at the expense of my minor, becoming a double major. So because I had not thought that through and not known to ask that question, it would have been better off for me just to take the organic 1 and 2, and if I really needed to, I could have taken the biochemistry later. The same thing happens when it comes to the right physics courses. Really important to walk through and read through those and ask about the implications of taking specific ones. Looking forward on a lot of those upper level courses that you might want to take. Again, this takes a lot of pre-reading, a lot of pre-planning, so that you've got really concise questions when you go in for your advisement appointments. I highly recommend taking as much math as possible, and statistics is quickly moving towards modeling. One should think about particularly making sure that you're going to learn the statistics program R these days, and when it comes to spatial statistics, thinking about ways to pick up some experiences in undergrad in ArcGIS and Geographic Information Systems is critical for this particular area. Thinking about how this goes through, so thinking about the general education requirements. You've got the general ed requirements that you need for the courses that meet these. There are other courses outside that meet some of these areas where you've got core competencies, and ones that are going to meet this. So you have to complete 40 credits of Gen Ed. Now some of these will fall in, but you do need to think about whether you want to have a major or minor, or a double major. So when it comes to the general education requirements, things that are allowing you to understand history and things like that in humanities, I was able to take a history in the sea course, which was really an incredible view on humans' interactions with the ocean for the long arc of history. There are other courses that you get a chance to take. I took a Spanish minor, which was really important for the work that I do now, and led to my eventual capacity to be able to perform well enough to be able to get a Fulbright award. And those are really important skills beyond what's just within the science and the science preparation for your broader career. So the additional piece that I would have with this is, remember that there are some requirements when it comes to paid internships. A lot of paid internships don't like to necessarily take people who are just through 1 year of college, but there are some out there. And most of them like to have folks who've had at least that first year of science basis, so they know they're trainable at that point. So that's the other key piece to your undergraduate education, is making sure you're getting experience, making sure you're working with people, and making sure you're networking. So the coursework is the coursework, but as an advisor, I would always tell students, think about attending a conference as an undergraduate. So try to work with labs on campus during the semester if you can, to start to get some experience, so that you might be able to at least present a poster at a conference, which is where people from around the country come once a year, and that's where you'll actually get a lot of really high profile networking done and potentially a job. The other piece is really making sure that you get internships. A lot of campuses have paid internship programs for their students. The University of Rhode Island had the Coastal Fellows program, and they did have a really great program called the SURFO program for people who were not from URI, for down at the Graduate School of Oceanography. So there are a lot of lists out there and other resources to be able to find these. But generally, a paid internship in the sciences will pay between $4,500 and I've seen up to $8,000 or $9,000, plus usually funding to get there, putting you up, and having some additional skills building during the program. Those are incredibly important experiences, and they generally are those that will allow you to work into a job or a graduate school with that type of experience later on. So that's all for today. Thank you very much for listening, and feel free to contact us. And all of this wouldn't be possible without a little bit of coffee, so check out our coffee offerings as well. Thanks.